This is A2U5L6. We're going to be dividing polynomials, and we're going to work our way into long division of polynomials before it's over. So let's start off with number one. We are going to review first what to do when you divide a polynomial by a monomial. Now you have to remember that every single term in the numerator is attached to the denominator by itself. So what I like to do for my first step is rewrite the numerator like this, and then I like to put each term over its own denominator, because when I start canceling out, I don't want to lose anything or think I've already done something. So this is just an easy way to give me a clear space to cancel out each term. All right, now you just simplify each monomial. Now 6 will go into, or 3 will go into 6 two times, and x to the fourth over x squared will leave me x squared. So my first term simplified is 2x squared. All right, minus. Now here, 15 over 3 leaves me 5, and x to the third over x squared reduces down to just x. All right, here, 3x squared over 3x squared is just 1. So that's your final answer. Okay, number 2 is 21a to the 5th b to the 3rd minus 14a cubed b squared plus 63a squared b all over a monomial. So just like the other problem, I'm going to rewrite every term in the numerator and put it over its own denominator so that I will have room to do all my canceling out, and I can see what I've done. Over 7ab. Okay, let's just cancel each one. So 21 over 7 leaves me with 3. A to the 5th over a gives me a to the 4th, and b to the 3rd over b gives me b squared. Right over here, 14 over 7 is 2. A to the 3rd over a gives me a squared, and b to the 2nd over b gives me b. And then here, 63 over 7 is 9. A squared over a is a, and b over b just makes 1, so I don't have to write it. And that's your answer. Okay, in this section we are going to look at how to divide a polynomial by a binomial, or really another polynomial. So we don't have a monomial denominator anymore, we have a polynomial. Now, one thing I do want to remind you about is what you can and cannot cancel. There is a difference between w plus 2 over 2 and 2w over 2. The difference being these two are added, this is a sum, and these two are multiplied, so these are both factors. Now on this one, you actually cannot cancel anything out. You can't cancel the 2's out because only factors cancel. And 2 is not a factor, it's a term. Now if you look down here, 2 and w are factors. So this one you could cancel and get w. But this one you cannot cancel. That is not equal to w. Okay? So keep that in mind. If we're going to cancel a binomial, it has to be the whole binomial, the whole set of parentheses. So now let's look at number 3. I have trinomial divided by binomial, so polynomial by polynomial. And you don't want to split it up because that just creates another mess. So the way you do it is you factor numerator and denominator as much as possible. So I'm looking at my numerator, and this is going to unfold because there's no greatest common factor and no coefficient here. So I'm going to take the square root of the first term here and here. All right, your plus sign tells you that your signs are going to be the same, and they're going to be whatever this is, minus and minus. So now I need a pair of numbers that will multiply to give you 10, but add up to give you 7, 2 and 5. And we're going to put that over w minus 5. Now, factors cancel. This whole thing is a factor. This is a factor. This is a factor. So what I can do here is those two whole things can cancel, and now my final answer, I'm just left with w minus 2. Okay, let's look at number 4. We have trinomial divided by binomial, and Once again, the only way to go is to, for now, is to factor this. So I look at my trinomial, I see there is no greatest common factor. I do have a coefficient in front of the first term, so I'm going to have to use the AC method, or you can use the slip and slide or guess and check, whichever one you want to. I always pick the AC method. And if you're a little bit fuzzy on these methods, I'll drop a link down in the description where you can go back to the lessons we had on factoring and brush up on that. But the AC method, I'm going to multiply A times C and get -8. And I'm looking for a pair of numbers that will multiply to give me -8, but add up to give me -7. So that's going to be -8 times +1. Now, when it's the AC method, your goal in the next step is to split this into those two numbers. So I'll do 8h plus 1h, and you can just put the h, minus 2. And then we still have the divisor down here, h minus 2. Okay? So we are going to group and then factor by grouping. Greatest common factor here is 4h. And when I factor that out, I'm going to get h minus 2, sorry. All right, over here, what's my greatest common factor between h and 2? Nothing, so you put a 1. You can always divide a 1 out. So I'm still going to have h minus 2, and then all of this is still divided by h minus 2. Okay, so to continue factoring, now I have 4h plus 1, and then in my second set of parentheses, h minus 2. And I'm going to go ahead, since this is divided by h minus 2, I'm just going to make it a fraction at this point because I'm running out of room mainly. All right, now you have factor, factor, and denominator. So the denominator can cancel with any factors in the numerator. So this and this can cancel, and now all you have left is 4h plus 1. Okay, let's look at number 5. So we have this beginning polynomial. We need to factor it. Now there are 4 terms. So first look for a greatest common factor, and there's not one. So we're going to factor by grouping. I'm going to group this and take out the greatest common factor. Now the greatest common factor between these two is x squared. So I'll have x plus 9 left. All right, the greatest common factor here is 4. Now this is a minus sign, so it's going to change the sign when you pull it out. So this is going to be x plus 9, okay? And we'll just go ahead and, one more time we'll put x plus 9 over here. All right, now taking this as the greatest common factor will be x plus 9, and then what's left over? The x squared minus 4. And then all of this is over x plus 9, okay? So now you can already see these two things cancel out. And what you have left is x squared minus 4. But hold on, because you can factor x squared minus 4. So you have to go ahead and factor it on out. And this would be x plus 2, x minus 2. And I just used the difference of two squares formula. So this is what the correct final answer would look like. Okay, for number 6, we start off, we have this 4-term polynomial divided by a binomial. So the first thing we're going to do is factor. There is no greatest common factor. Since I have 4 terms, I'm going to factor by grouping. So I'm just going to group 2 and 2. All right, the greatest common factor here is just n to the second power. So when I factor it out of this, I'm going to get 2n plus 3. All right, I come over here and my greatest common factor is 8. Now remember, I'm factoring out a minus 8, so it's going to change this sign. So I'm going to have 2n plus 3. And technically, I should put this in brackets so I can tell that all of that is divided by 2n plus 3. Okay? Now, the 2n plus 3 becomes my greatest common factor for both terms here. So I'm going to have 2n plus 3, and then I have the n squared minus 8. And since this is division, I'm just going to go ahead and draw my fraction bar and put 2n plus 3 on the bottom. Now, factor, factor, denominator. So your denominator can cancel with either factor, and it does cancel with this one. And now what I have left is n squared minus 8, okay? Can you factor that any further? No. It's not, 8 is a perfect cube, but n squared is not. And n squared is a perfect square, but 8 is not a perfect square. So that's going to be your final answer. Okay, what we just looked at was division of polynomials, and the thing was, all those problems we've had in the past, you've been able to factor the numerator. So we're fixing to look at some problems where you can't factor the numerator, and we had to have another method. Now, it very much resembles how you used to do division back in elementary school, and since it's been quite a few years for some of you, let's just work one like that so you can kind of get the motion back in your head. All right, what you did is you would say, here's my divisor. How many times will it go into 1? And it won't go, so you moved over to the next number. You said, okay, how many times will 12 go into 18? And it would go 1. So you said, all right, then you multiplied. 1 times 12, and then what'd you do? You subtracted. 18 minus 12 was 6. And then you brought down the next number. And you started all over again. You said, how many times will 12 go into 62? Well, it'll go 5 times. Remember, you had to know your facts as well. 5 times 12 is 60, and then you subtracted, so you got 2, and then you brought down that number. So now you had 24, and you said, well, how many times will 12 go into 24? And that was 2, so you had 24, and hopefully you got a 0 here. If not, you had a number and you had to put like remainder of that number, or you would even put this number over that one, the fraction. So all of those things should be coming back now, because that's almost exactly the same technique that we're fixing to use with polynomials. Okay, so for number 7, let's just look at what this polynomial long division is going to look like. I'm going to take my divisor down here at the end, and it's going to be in front. I'm going to draw the fraction symbol of the house. Then I'm going to take my first number, my first polynomial, and I'm just going to put it under the house, because this is my dividend. It's what's going into it. Okay, so now we're only going to focus on the first term in our binomial out here, just the r. And I'm going to ask myself, how many times will r go into r to the third? Or better yet, r times what would give me r to the third? Well, r to the second, right? And we're going to put that number, we're going to slide over, and we're going to put it here. Just because it's better if your terms match according to exponents. So that's where we're going to start. Now, just like with the other one, we're going to multiply, come back around. R squared times r is r to the third. So we're going to keep it lined up. And then r squared times 3 is plus 3r squared, okay? Now, just like with the other method, we're going to subtract. Now, your whole goal for each step is to have your first two numbers match so that when you subtract, they disappear. Now, you can't control the second number because you just have to multiply whatever you have times this. You're stuck with that. But your goal is to get the first terms to eliminate. All right, so r to the third minus r to the third eliminates. Now, what is negative or minus 4r to the second minus 3r to the second? Well, that's minus 7r to the second. Then we're going to come over here, and we're going to bring this number down. Okay, now it starts all over again. How many times will r go into negative 7r squared? Well, minus 7r times. Then we're going to swing back and multiply. Minus 7r times r is minus 7r squared. And right here, I'm thinking goal complete, because that was my goal, was to make the first terms match. Now on the second term, I just get what I get. So negative 7 times 3 is negative 21r. And then we're going to come out here and subtract. All right, set negative 7 minus negative 7 is 0. Negative 26 minus negative 21, that changes to plus a positive. So we have negative 5r, and I'm going to bring the minus 15 down. Okay, so now I ask myself, how many times will r go into negative 5r? Well, negative 5 times. So when I multiply negative 5 times r, I get negative 5r. And when I multiply negative 5 times positive 3, I get negative 15. Now, since those two match, when I subtract, I get a 0 remainder, which is fantastic. So what I have up here is my final answer. R squared minus 7r minus 5. Okay, here's number 8. So let's go ahead and get it into our format. We're going to put k minus 1 on the outside here. And then I'm going to take k to the third minus 8k squared minus 3k plus 8. Okay? And let's get going. Take your first term here and ask yourself, how many times will it go into k3, or what would I multiply times k to get k to the third? Well, I would multiply times k to the second, and I'm going to put it over here so that it's in the same place with matching exponents. Okay? Now, multiply. K squared times k is k to the third. Goal achieved. K squared times negative 1 is minus k squared. And subtract, watching negatives. All right, these two cancel out. So now I have minus 8k squared minus a negative k. So that changes to plus a positive. So I have negative 7k to the second. And then I'm going to bring this down. All right, now what would I multiply k by to get negative 7k squared? Well, a negative 7k. So now I do negative 7 times k, and I get negative 7k squared, goal achieved. Negative 7 times negative 1 is positive 7k. And I'm going to subtract. And remember, I did subtract up here, I just changed it because it was plus a positive. Okay? So now, these two cancel. Negative 3 minus 7 is negative 10k. And then the 8 comes all the way down. And I go again. What would I multiply k by to get negative 10k? Negative 10. And then let's multiply. Negative 10 times k is negative 10k. And negative 10 times minus 1 is positive 10. So then when I subtract, these two cancel. What is 8 minus 10? Negative 2. Well, now you have a remainder. So this is how you write your remainder. I'm going to come over here to the side. We're going to have all this for our final answer. K to the second minus 7k minus 10. You take your remainder, whatever sign it has, that's what goes there. Then your number becomes a numerator, and this is your denominator, whatever number that is, or whatever polynomial. Okay, so it would be minus 2 over k minus 1. Okay, let's have a go with number 9. So I'm going to take my divisor and I'm going to copy it on the outside of the little division house. And then underneath, I've got 6n to the third minus 20n to the second minus 42n minus 47. Okay, so let's get going. Go to your first number. Say, what would I multiply by this number to get 6n to the third? And remember, it goes on top of this. So that would be 6n to the second. Okay? And now let's multiply. 6n to the second times n is 6n to the third. And then 6n squared times negative 5 or minus 5 is going to be minus 30n to the second. Okay? Let's subtract. These two cancel. Now a minus 20n minus a negative 30n, these two change to plus a positive. So negative 20 plus positive 30 is going to be positive 10n to the second. And then we're going to bring down minus 42n. Okay? Now, how many times will n go into 10 to the second power? Well, it's going to be a plus 10n. All right, 10n times n is 10n squared. 10n times minus 5 is minus 50n. And let's subtract, watching out for our signs. These two cancel. Negative 42 minus a negative 50, this would change to plus a positive, so you're going to have 8n. And then we're going to bring that 47 down. Okay? How many times will n go into 8n? Positive 8 times. 8 times n is 8n. All right? 8 times minus 5 is minus 40. Now we're going to subtract. These two cancel. Negative 47 plus 40, because minus a negative cancels out, is going to give you negative 7. Now there's your remainder. So when you write the rest of your answer, and let's just add it onto this time. This is a minus, so it's going to be minus 7 over your divisor right here, n minus 5. And this is your final answer. Okay, so let's look at number 10 now. We're going to take our divisor right here and we'll put it on the outside of the division symbol. Then we're going to have 3a to the third power minus 7a to the second minus 30a minus 21. And once again, we're going to focus on these two numbers first and say, what would I multiply 3a by to get 3a squared? And I'm going to put that answer on top of this one. So that would just be a squared. And then I'm going to multiply. A squared times 3a is 3a to the third. And a squared times 2 is positive 2a to the second. And then we will subtract. So those cancel out. Goal achieved. Negative 7a minus 2a is going to give me a minus 9a squared. And then I bring down that minus 30a. Okay? Starts all over again. What would I multiply 3a by to get negative 9a squared? Well, that's going to be a negative 3a. 3a times 3a gives me negative 9a squared. Negative 3a times 2 gives me negative 6a. And then I'm going to subtract. These two cancel out. Negative 30 minus negative 6 is the same thing as plus a positive. So that gives me negative 24a. And then I'm going to bring down the minus 21. All right, then I say, what would I multiply 3a by to get negative 24? Well, that's going to be a negative 8. And then let's multiply. So I get negative 24a. Negative 8 times 2 is negative 16. So then I'm going to subtract. Those two cancel out. Negative 21 minus a negative means plus. So negative 21 plus 16 is negative 5. And this is your remainder. So what we're going to do is we're going to come up here and just put minus, because that's negative. And then we'll put 5 over 3a plus 2. Okay, in our last four problems, they've added one more little difficulty, and that difficulty is there's a missing power. Your dividend has to be written in descending order of exponents, and you cannot skip any. So, for example, this one skips the k squared. There's no k squared. What we're going to do is we're going to use the placeholder. We've done this before, but I don't know if you remember it. 0 times anything is 0. Anything plus 0 doesn't change the value. So what we're going to do here is we're going to say, well, if I rewrote this, and we'll go ahead and put our divisor on the outside. So I've got k minus 3. Now when I write this under here, when I come to the one that's missing, I'm just going to add 0k to the second. Because 0k to the second is just 0. So I'm holding the place, but I'm not changing the value. And you do that for as many of them as you're missing. So now I've got minus 9k minus 2. Okay? So you see I've got a 3, a 2, a 1, and then k to the 0. All right? So let's just go as we've been doing. What would I multiply k by to get k to the third? K to the second. Now you multiply. K times k squared times k is k to the third. And k squared times negative 3 is minus 3k. k squared. And we're going to subtract. These two cancel out. Now, 0 minus negative 3 is positive 3. So I'm going to have 3k squared. And then I'm going to bring down the minus 9k. All right, now, what would I multiply k by to get positive 3k squared? Well, that would be positive 3k. 3k times k is 3k squared. And 3k times minus 3 is minus 9k. So these cancel out entirely. So I have 0k. And then I'm going to bring down the negative 2. Okay? So what would I multiply k by to get 0k? How about just a 0? So when I multiply 0 times k, I get 0k. 0 times minus 3 is just 0. You just keep doing the things that you've been doing. All right, negative 2 minus 0 is negative 2. Now this is your remainder. See, I don't have any numbers left here to bring down, so this is your remainder. So our final answer on this one is going to be k squared plus 3k. You don't have to write the 0 down, minus 2 over whatever our divisor was, which was k minus 3. Okay, for number 12, I already noticed that I'm missing a power. I'm missing the a to the second power. So I'm gonna put my divisor out here, and draw my division sign. So we're gonna insert a 0 a to the second power. So I've got a to the fourth plus 8a to the third plus 0a to the second minus 3a minus 16. Okay, let's roll. What would I multiply a by to get a to the fourth? A to the third, and we're going to put it up here over its matching exponent. Now we're going to multiply. A to the third times a is a to the fourth. A to the third times 8 is 8a to the third. And then we're going to subtract. So now, these all cancel out. So what I have here is 0a to the third. I'm going to bring this down, which is weird, but you know, just work with it. 0 is a number. You can subtract or add with or without 0. All right, what would I multiply a by to get 0a to the third? Well, how about 0a squared, right? So now let's multiply. 0a squared times a gives me 0a to the third. And 0a squared times 8 gives me 0a squared, okay? And we're going to subtract, and those cancel out. So now I have 0, let me come up a little bit, 0a squared, and I'm going to bring this one all the way down, minus 3a, okay? Just keep going. Now, what would I multiply a by to get 0a squared? Well, another 0a. All right, so multiply. 0 times a is 0a squared, and 0a times 8a is positive 0a. And now we're going to subtract. These two cancel. Negative 3a minus 0 is negative 3a, and then I'm going to bring down the minus 16, okay? Once again, what would I multiply a by to get negative 3a? Well, by negative 3. So negative 3 times a is negative 3a, and negative 3 times 8 is negative 24, okay? Let's subtract. These two cancel, so negative 16 plus 24 will be positive 8. Now remember, that's going to be your remainder. So the way we're going to write our final answer, I don't need to write those two in my final answer. So I'm just going to have the a to the third minus 3, and then plus 8 over a plus 8. Okay, on number 13, I noticed right off the bat that I'm missing my a to the third power. So let's take our divisor, and we're going to put it on the outside of our little division house. Now we're going to have 3a to the 4th. All right, I need to put a place in here. Now remember, this minus sign belongs to the 20. So what I'm going to insert is a plus a to the 3rd. And then I'll have my minus 20 a to the 2nd minus 6a plus 14. Okay, so let's roll. What would I multiply a by to get 3a to the 4th? Well, that would be 3a to the 3rd, and it goes on top of the a to the 3rd term. Now multiply 3a to the 3rd times a is 3a to the 4th. 3a to the 3rd times 2 is positive 6a to the 3rd. And let's subtract. Those two cancel out. 0 minus 6 is going to be negative 6a to the 3rd. And then you bring this down. Okay, go again. What would you multiply a by to get negative 6a to the 3rd? Well, that would be negative 6a to the 2nd. 6a to the 2nd times a is going to be negative 6a to the 3rd. And negative 6 times 2 is negative 12a squared. And we are going to subtract. Now, negative 20 minus negative 12 changes to plus a positive. So that's going to give you negative 8a to the 2nd. And we're going to bring down that minus 6a. Okay. Now, what would I multiply a by to get negative 8a squared? Well, that would be negative 8a. So negative 8 times a is negative 8a squared. And negative 8 times 2 is going to give me negative 16a. And then we're going to subtract. So these two cancel. Now, negative 6 minus negative 16 changes to plus a positive. So you have 10a. And we're going to bring down that plus 14. Okay. What would you multiply a by to get 10a? Well, that's going to be plus 10. And 10 times a is 10a. And 10 times 2 is 20. And we will be subtracting. So these two cancel out. 14 minus 20 is negative 6. Now that's your remainder. So when you write your answer down, you're going to have all of this minus 6 over a plus 2. And that's going to be the final answer on that one. Okay, here's number 14, and the first thing I notice is I have a w to the 3rd, a w to the 2nd, and then a constant. So I'm missing a linear term, a w to the 1st term. So let's get our divisor, and let's do 4w minus 3 here. Now, this is going to be 36 w to the 3rd minus 27 w squared. All right, I'm going to insert that plus 0w and then minus 6. Okay, so what would I multiply 4w by to get 36w to the 3rd? And remember, it's going to go here. That would be 9w to the 2nd. All right, multiplying gives you 36w to the 3rd minus 27w squared. So when you subtract, you get 0w squared here, and you get positive 0w. Don't let it mess with you. 0 is a number. So what would you multiply 4w by to get 0w squared? Well, that would be times 0w. 0 times 4 is 0. W times w is w squared. All right, what is 0w times negative 3? 0w. What do you get when you subtract 0 minus 0? You still get 0w here. Remember, this is the place you're trying to eliminate. This is the place you're bringing down. All right, so this one comes all the way down, minus 6. Okay. What would you multiply 4w by to get 0w? 0. 0 times 4w is 0w. 0 times negative 3 is minus 0. Okay? So negative 6 minus 0 is still negative 6, and this is your remainder. But now when you write your answer, you don't have to write those two things down. So your final answer is just going to be the 9w to the second minus 6 over 4w minus 3. And that is all. And the more you practice this, the more that's going to become muscle memory, and you won't have to think so hard about what goes where and what to do next.